Okay. Now we can start again. Okay, with it. Sorry for the network issue. Okay. Hi. So what I was discussing today's lesson. It's about today's lesson. This will be very critical lesson. So please listen to me very carefully. If you have any doubt, please let me know that one. And if you want to discuss anything, please let me know. Okay. Okay. Okay, now we can start with it. They write a topic, calorimetry. Calorimetry. Okay. If you want to have very good idea, very good understanding about heat, the first thing you should know, you have to have very good knowledge about thermal energy and temperature. And what is the difference between thermal energy or heat and temperature? Okay. Can anyone tell me what is the difference between heat and temperature? Because you have learned that thing in orals. So if anyone have that knowledge, could you please let me know? What is the difference between heat and temperature? Heat and temperature. Okay. Okay. Before learning about heat and temperature, we have to learn about the matter. Matter means objects. What is the matter? So, last one, energy.
Matter is having mass and occupy space.
Yes, that is matter. We are going to learn about the inside of matter. What is it made of? Matter. If we consider about matter means matter or an object. Matter or an object. They are made of very small particles. No, they are made of very small particles. They may be a atom. They may be a molecules. No, yeah, atoms or molecules. Anything. Every matter or every object are made of very small particles. Very small particles. Okay. Either it may be atoms or molecules or anything. Okay. So commonly we can use the word particles. So every matter or every object is made of very small particles. So these particles are bound together by intermolecular bonds. No, bound together by some bonds. We call them as intermolecular bonds. No, those parts actually, if there are particles without any attraction force, actually there won't be a matter or there won't be a object. Therefore, definitely there should be some attraction force between them, or they should be bound together. How they bound? There is a intermolecular bond, intermolecular attraction force. There are intermolecular attraction force between those particles. Normally we call them as intermolecular bonds. Intermolecular bonds. They are intermolecular attraction force in between those particles. So that attraction force are called as intermolecular bonds. Actually, you know some bond types. No, there are so many type of bonds: covalent bonds, ionic bonds, metallic bonds. Likewise, there are so many types of bonds. Okay, but if there's an object, that object is made of very small particles. Those particles are bound together by intermolecular bonds. Okay. Okay. Did you get my point up to now? Do you have any questions up to now? No. Very good. Okay. So this is the nature of the matter. Nature of the matter or nature of an object. So every objects are made of very small particles where there are intermolecular attraction force. We call them as intermolecular bonds between those particles. Okay. Then write the topic. Write the topic. Nature of nature of nature of nature of matter or object. Objects. Nature of matter and objects. Yes. Yes. The main topic is calorimetry. The main topic is calorimetry. Under the main topic, the first subtopic. This is the first subtopic. Nature of matter or objects. Okay, you can draw this one. You can draw this figure. Those are particles. Those are particles. And the molecular bonds. Okay. Then look at the board. Look at the board. Everyone. Now we have discussed about the structure of the matter or any object. This is the structure. Okay. The structure means there are some every matter or every object is made of some small, very small particles. They may be atoms or molecules. In between those particles, there are attraction forces. Those attraction forces are called as intermolecular bonds. Okay. So matter to matter or object to object, the strength of intermolecular bonds varies. Okay. So some intermolecular bonds are very strong, some are very weak. So according to the strength of intermolecular bonds, there are three states of matter. Three states of matter. What are those? What are those? Tell me.
Solid, liquid, and gas.
Very good. Very good. Solid, liquid, and gas. Very good. So if we consider about solids, the intermolecular bonds between these small time particles are very strong. They are bound together very strongly. Okay. So when we consider about gases, actually we can neglect intermolecular bonds. They are very, very weak. Therefore, normally in thermodynamics, normally we consider about ideal gas. In ideal gas, we neglect intermolecular bonds. Okay. Therefore, the intermolecular bonds between gas particles are very weak, while the intermolecular bonds between solid particles are very strong. Okay. Therefore, gas particles can move here and there, but solid particles cannot move here and there because they are bound together by very strong forces. Okay. So depending the strength of intermolecular bonds, there are three sets of matter. Okay. Okay. We can note down those things. Write down this thing. Any object or matter is made of particles, is made of very small particles, is made of very small particles. Within the brackets, maybe atoms or molecules, close the bracket. These particles are bound together. These particles are bound together by intermolecular bonds. Intermolecular bonds.
Can you please repeat?
These particles are bound together, bound together by intermolecular bonds. Intermolecular bonds. Write in another paragraph. Depending on the strength, depending on the strength, depending on the strength strength of intermolecular bonds, there are three main states of matter. There are three main states of matter. Solid, liquid, gas. Very short intermolecular bonds. IMB means intermolecular bonds. Okay. IMB means intermolecular bonds. Okay.
Excuse me, sir.
Yeah.
So in the gaseous state, is it wrong if we take that there are no bonds?
Sorry.
In the gaseous state, is it wrong if we take that there are no intermolecular bonds?
Yeah. If we consider about ideal gas, there are no intermolecular bonds, but it is ideal state. But the actual state, there are bonds, but they are very weak. They are very weak. Therefore, we cannot say there's no bonds in gases. There are bonds, but they are very weak. But in ideal state means it is an assumed state. That is state we do not consider the intermolecular bonds. Okay.
So that means actually there are no bonds between them?
No. Actually, there are bonds. They are very weak. Okay. But for calculations, normally we assume them as zero strength. Okay. That is about gases. Okay. We will learn that. We learn that about in gas section. So we are going to learn about the actual gas as well as the ideal gas. Okay. In the actual gases, there are intermolecular bonds, but the thing is they are very weak. That's all. Okay. Shall I erase this one? Okay. Sorry, Budhe. Your voice is may not clear, Buddha. Irishino? Shall I erase Buddha? Okay, thank you. Okay. Then, now we know about the structure of matter or any object. According to the structure, there are very small particles. Now we are going to discuss about the nature of the particle. That means the how they are within the matter or within the object. So what are the characteristics of those particles? Okay, now we are going to study about the nature of that particles. Okay, nature means the characteristic of those particles. Okay. Okay, write down a second topic, second subtopic. Nature of inner particles. Nature of inner particles. Nature of inner particles of a matter. Of a matter. Of a matter. Right. Okay. We know every matter is made of very small particles, and in between those particles there are intermolecular bonds. That means they are bound together. They are bound together by intermolecular bonds. Normally, those particles are not stationary particles. Okay, although they are bound together, although they are bound together between the other particles, they are not stationary particles. Okay, they are not stationary particles. In normal conditions, normally they have motions. No motions means normally they are vibrating. They are vibrating. Normally they are vibrating. Oh, normally they are vibrating, and if we consider gases, not only vibrate, they can move also. They can move. Okay, but in solid and liquids, normally they are vibrating. Okay, so these particles are not stationary particles in normal conditions. They are vibrating. Therefore, they have a motion. They are not a stationary particles. Okay, so that is the nature of those particles. Okay, so that means those particles have intermolecular bonds in between those particles. There are intermolecular bonds. Not only intermolecular bonds, they have a vibration. They have a vibration. Okay. Yeah. Yeah. I will come to that part. Okay. You got that thing. Okay. That means they have a vibration. Okay, they have a vibration, Buddha. And so every particle in that matter have a vibration. Have a vibration. They are not a stationary particles unless they are at the absolute zero. Okay, absolute zero means that is the lowest ever temperature in the universe. The lowest ever temperature in the universe. The absolute zero. It is not Celsius zero. Okay. That is where it is equal to Celsius minus 273. 273.15 Celsius. This is called an absolute zero. Absolute zero means if we measure this value using Kelvin scale, it is zero. We know the SI unit of temperature. SI unit of temperature is Kelvin. So normally we call this scale as absolute scale. Okay, because it starts from the absolute zero. Okay, we will learn these scales in later. So the absolute zero value is equal to minus 273. So minus 273 means that is the lowest ever temperature in the universe. So at that temperature, all the metals are freeze. Okay, so there won't be any vibration or any motion at this temperature. Okay, so all the temperature other than absolute zero, there will be a vibration. There's a vibration. Okay. Okay. So that is the nature of those particles. Okay. Do you have any question? Or did you get my point? තේරුණාද හැමෝටම මේක concept එකක් මම concept එකක් කියලා දෙන්න හදන්නේ තේරුණාද? Okay. Write the topic, the nature of inner particles of matter. Type of book. Right under that. At any temperature, zero Kelvin means we cannot go to that temperature. Actually, we cannot reach that temperature because if you want to reach that temperature, we will not exceed. That's a problem. Okay, so but as a theoretical value, it is exist. Okay, as a theoretical value, like speed of light. We cannot reach to speed of light, no. But there is a theoretical value for speed of light. This is the highest ever velocity. That is highest ever velocity. Likewise, this is the lowest ever temperature. Okay, this value is a theoretical value, but practically we cannot reach to that value. Okay. At any temperature other than absolute zero, absolute zero, absolute zero, every particle, comma, every particle in an object or matter, in an object or matter, in an object or matter.
So can you repeat after absolute zero?
So what is the first one? At any temperature, other than absolute zero, at any temperature other than absolute zero, comma, every particle in an object or matter. Oops. Has a vibration. The ability to vibrate. The ability to vibrate depends on the nature of matter. The nature of matter. The nature of matter. The ability to vibrate depends on the nature of matter. What does that mean? Can anyone explain that to me? So give another explain.
In solids, the particles are tightly packed, so they cannot vibrate.
Yes, very good. Yes, very good. Nature of matter means you know about solid. The solid means intermolecular bonds are very strong. Intermolecular bonds are very strong and they are compact material. No, compact material. Compact material means there are a lot of particles around one particle. No, they are closely packed. So they can't move easily. They cannot move easily. But they are moving, but the ability of moving is very low. But they are moving. But the thing is, it is very hard. But if we consider about a gas material, the intermolecular bonds between gas particles are very low. Therefore, they are free to move. And the number of particles per unit volume. Is very much low. So there are a lot of free spaces among gas. No, therefore they can move very easily. Private bus එකක කතා කරලා හිතා ගන්න. private bus එක යනකොට move වෙන්න පුළුවන්ද? ටිකක් අමාරුයි නේ. ඒවට අපි පිට්ටලි කරා වගේ දැම්මා බොහොම ලේසියෙන් අපිට move වෙන්න පුළුවන් නේ. හරි. ඒ වගේ තමයි අර solid closely packed එකයි අර free packed එකයි කියන අතර වෙනස. හරිද? Therefore, if you consider about a solid material, the ability to vibration is relatively low. But if we consider about gas material, they can move very easily. Okay. Write down, right under the the previous paragraph. Example. The first one. Particles in solid material. Particles in solid material. Particles in solid materials. Particles in solid materials are tightly bound. Tightly bound. Tightly bound. So vibrations. So vibrations. So vibration is a little difficult. Okay. Particles. Can anyone tell me the last sentence?
Particles in solid materials are tightly bound, so vibrations is a little difficult.
This is the first point. The second point. The second point. As the intermolecular bonds, as the intermolecular bonds, as the intermolecular bonds.
Is it a new example?
Sorry.
So should we write this as a new example?
No, actually, I'm giving two examples of the first example. First point is about solid material. This is the second point. This is the second point. As the intermolecular bonds, of gas particles, are very weak, those particles can move very easily. Sorry, Uday. Those particles can move very easily. Last sentence. As the intermolecular bonds of gas particles are very weak, those particles can move very easily. Okay. Hari. Actually, when we were discussing about the nature of particles, there was a word absolute zero. No, so we can define that thing. Define that thing means we can write that thing as a very simple definition, but absolute zero. Okay, write a topic absolute zero. Absolute zero. Absolute zero. Absolute zero is the lowest ever temperature in the universe. Is the lowest ever temperature in the universe. In the universe. Lowest possible, lowest possible. This is the lowest possible temperature. It is the lowest possible temperature in the universe. That means, please cut the word may ever. It should be the lowest possible temperature because there is no any temperature less than the absolute zero value. We can prove that thing in Charles law and other Gauss laws. So this is the lowest possible temperature in the universe. Okay. Okay. At this temperature, every particles stop their motion. Stop their motions. All right. Look at this one. Absolute zero. The absolute zero value is equal to minus 273.15 Celsius. Normally, approximately, we can take it as 273 minus 273 Celsius. Okay, and it is equal to 0 Kelvin because Kelvin is the absolute temperature measurement, temperature scale. Okay. So therefore 0 Kelvin is equal to minus 273 Celsius. So that means if you add 273 to both sides, if you add 273 to both sides, then we will have 0 Celsius and 273 Kelvin. Okay. 273 Kelvin is equal to 0 Celsius. By adding 273 for both sides, no? That means the Kelvin scale is higher than 273 we can get Kelvin scale by adding 273 to Celsius scale. We can get the Kelvin scale by adding 273 to Kelvin. We can get the Kelvin scale by adding 273 to Celsius. Celsius 0 is equal to 273 Kelvin. So Celsius 1 is equal to 274. Celsius 2 is equal to 275. Celsius 5 is equal to 278. Likewise, that means suppose if we add equal 27 Celsius, no? 27 Celsius. If we add 300 to both sides, 300 Kelvin is equal to 27 Celsius. Okay. Now, what do you come? 274 Kelvin is equal to 1 Celsius. I have add 274 for both sides. If I add 275 for both sides, 275 for both sides, it is equal to 2 Celsius. 275. That means the Kelvin scale is equal to Celsius scale plus 273. 273. Kelvin scale is equal to Celsius scale plus 273. Okay. Did you get my point? Absolute 0 is equal minus 273. So that is equal to 0 Kelvin. So 0 Kelvin is equal to minus 273. If I add 273 for both sides, then 273 Kelvin is equal to 0 Celsius. If I add 274 for both sides, 274 is equal to 1 Celsius. If I add 275 for both sides, that means Kelvin scale is equal to Celsius plus 273. 273. Actually 273.15, but for calculations, if it is not mentioned, normally we what about ISS? Actually, it's about we have to add 275, 273.15, but for calculation, if it is not mentioned, normally we assume it as 273. These 2 points, we won't consider about these 2 points because 0.15 is very small value. Okay. But if it is mentioned, no, if it is necessary, then we have to consider about 0.15. Okay. Otherwise, we can neglect that thing. Okay. This is approximately minus 273 Celsius. Otherwise, you will think, what about 0.15? This is approximately equal to 273. ඒක දාගන්න නැත්නම් ඕගොල්ලන්ට ආයෙත් මතක් වෙයි මොකක්ද යක 0.15 ට මොකද උනේ කියලා. Okay. Shall we do some examples? Shall we do some examples? So 27 Celsius. If we consider 27 Celsius, so it is equal 273 plus 27 Kelvin, that means 300 Kelvin. If we consider, sorry, 100 Celsius, it is equal to 273 plus 100, that means 373 Kelvin. Okay. Write the fourth subtopic. The fourth subtopic. Yeah, third is absolute zero. Third one is absolute zero. Fourth one is internal energy of an object. Internal energy of an object. You have to listen very carefully. Right, this topic, internal energy of an object. You have to listen very carefully for this explanation. Okay. According to the structure of matter, it is made of very small particles. Okay. Those particles are bound together by intermolecular bonds. Okay. And those particles have vibrations. Vibrations. Okay. Those are the things we know up to now. No, those are the things we know up to now. What are those things? Every matter or every object are made of very small particles. Those particles are bound together by intermolecular bonds. And those particles are not stationary particles. They have vibrations. Therefore, they are vibrating around itself, around the equilibrium point. They are vibrating. Okay. So, if there is a vibration, that means there's a motion, Bhuta. If there's a motion, that means those particles have energy. What type of energy? Tell me. What type of energy?
Kinetic.
Yes, very good. So those particles have a kinetic energy due to the vibration. So if it is a vibration, there is a motion. So due to that motion, definitely those particles should have kinetic energy. Therefore, there is a kinetic energy internally within that object, kinetic energy. Okay, now there's a one type of energy. Look at the other. Listen to this very carefully. Look at the other. Okay. Those particles are bound together by intermolecular bonds. Therefore, if you want to separate one particle from the others, you have to break those intermolecular bonds, no? Otherwise, you cannot take that particle, no? No. So, if you want to separate one particle from the others, you have to break the intermolecular bonds. If you want to break the intermolecular bonds, you should provide some energy. You should provide some energy, otherwise those won't be break, no? Therefore, if you want to move or if you want to separate, so if you want to change the place of a particle, you should apply energy. You should apply energy. Therefore, that means due to these intermolecular bonds, those particles have some kind of energy. Some kind of energy. Did you get my point? Due to that intermolecular bonds, those particles have some kind of energy. That energy related to change its position. That means if we want to change the position of this particle, we have to apply energy. So that kind of energy is called as it is a potential energy. It is a potential energy. You know this thing. If you want to change the position, suppose this one, if this particle is now this particle is in this place, no? If we want to change the location or change the position of this particle, we have to apply energy, no? So that type of energy is called as a potential energy. Potential energy. I will later. No, this is okay. 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 So if we want to change the position of the particle, we have to apply energy. So that type of energy is a potential energy. Potential energy. So due to intermolecular bonds, there is a potential energy. Potential energy, because we have to apply a force. So not a force. We have to apply a energy to separate or to change the position of the particle. Okay. Suppose there is a ball. Suppose there is a ball. If you want to change the location of this ball, if you want to change the location of this ball, or if you want to bring this ball to the top of the mountain, you have to apply energy of that energy relates to potential energy. So if there is a position change, and if we need an energy to change a position, that type of energy is called as potential energy. Okay. If there is a motion of a particle, the energy relates to motion is called as kinetic energy. Energy relates to change of position is called as potential energy. Therefore, these particles have two types of energies. What are those? Kinetic energy due to the vibration, the potential energy due to the intermolecular bonds. Okay. Those two types of energies, the addition of those two types of energy is called as internal energy. Internal energy of that particle. So internal energy that particles means the addition of kinetic and potential energies. both kinetic and potential energies. Kinetic energy due to vibrations, potential energies due to the intermolecular bonds. Okay. Did you get my points? There or other?
Can you tension energy comes from the molecular bonds?
Sorry, Bhute, your voice is not clear. What, Bhute? Is she? Okay, tell me others. Do you have any questions or do you have any doubt? Or did you understood? Potential energy. Okay. Okay. If you want to change the place of particle, you have to apply energy. If you need to apply energy, that type of energy is called as the potential energy. That is a definition of potential energy. Definition of potential energy. So what is the definition of potential energy? So what is the definition of kinetic energy? Kinetic energy means energy related to motion. Energy relates to motion is called as the kinetic energy. Okay. So what is the definition of potential energy? Definition of potential energy? It's relates potential energy relates to change in position. No. There's no change in position. But if you want to change position, we have to apply energy. So that means there should be a potential energy. That suppose there's a ball here. No, there's a ball here. So if there's a ball, now the position is not going to change. But if you want to change the position, if you want to move that ball into this location, you have to apply energy. That energy is a potential energy. You get my point. So we are not going to change the position of these particles. But if you want to change the position of particle, we should apply energy. That energy should be potential energy. Therefore, there is a potential energy inside the particles. Did you get my point? Suppose this ball is on the top of the mountain. Okay. So if this ball is on this place, actually this ball has energy. This ball has energy. Yes, always have potential energy. If there's a intermolecular bonds, if we want to change the position of that particle, we have to break those intermolecular bonds. That means we have to apply an energy to change the position of that particle. So if we want to change the position of particle, we have to apply an energy. That means that particles already has a potential energy. Did you get my point? Otherwise, we don't want to apply energy to them. Otherwise, we don't want to apply energy to change this position. Something like this. If you want to change the position of this ball along a straight line, we don't want to apply energy, because the same position, same level, we don't want to apply an energy. But if you want to go upward direction, we have to apply mgh. You know that one, no? How to calculate potential energy? It is equal to mgh, no? So we have to apply potential energy. Huh? No, 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 no. Vibrated, vibrated only. Okay. As you listen, suppose those are my two hands. Those hands are holding by another two persons. Okay. Now we are going to shake our hands. Shake our hands. Okay. We can shake our hands without breaking our bones, no? We can shake our hand, no? We can shake our hands without breaking the bone, no? Okay. Therefore, without breaking the intermolecular bonds, they can vibrate. They can vibrate up to some extent. Up to some extent. Look at this one. Look at this one. If we suppose my two hands are holding hold by two other persons, and now we are shaking our hands. Okay, so up to some extent, those bonds won't be break. But if I increase my shaking speed, what will happen? What will happen? Sometime it can be break. It can be break. I will come to that point. I will come to that point. ඒක break වෙන්න පුළුවන් අවස්ථාවක් එනවා. Now up to that point, we can move without breaking the intermolecular bonds. Okay. Did you get my point? Issue? Did you get my point?
Yes, sir. Thank you.
Okay, thank you. Okay, everyone, they write the topic intermolecular bonds and draw this figure. Sorry, internal energy. Sorry, internal energy. Internal energy of right?
Yes,
Please draw this one.
is it the third bit?
Sorry. Sorry, Buddha?
Is it the third bit?
Your voice is not clear, Buddha. No, fourth one. Third one, absolute zero. This is fourth one. Internal energy of matter or object. This is a vibration. Intermolecular ones. Okay. Right under the figure. Hello. As we mentioned earlier, Matter is made up of particles. Matter is made up of particles. The particles are bound together by intermolecular bonds. Intermolecular bonds. And they are vibrating. They are vibrating. They are vibrating. They are vibrating at any temperature higher than absolute zero. Therefore, those particles contain the following energy types. The following energy types. Due to the vibration, due to the vibration, they have kinetic energy. They have kinetic energy. Due to the vibrations, of particles, they have kinetic energy. Kinetic energy. Second thing. If we need to separate
Sir, can you repeat, please?
if we need to separate or remove one particle from the others, one particle from the other, one particle from the others, an energy should be provided to break intermolecular bonds, I will explain, okay, after doing this one. Therefore, due to the intermolecular bonds, comma, energy should be provided to change the position of particles. So This is a type of potential energy. This is a type of potential energy. This is a type of potential energy. Type of potential energy. This is a type of potential energy. As it relates to as it relates to as it relates to change the position of particles. Change the position of particles. Change of the position of particles. As it relates to change of the position of particles. Within the bracket, the energy released or stored released or stored released or stored due to the change in position due to the change in position of an object due to change in position of an object is a potential energy. Okay. Everyone, please read that paragraph again. Tell me, do you have any question? Or if you get my points, please let me know. If you understood very well, please let me know. Thank you. What about others? Thank you. Okay. No, this is not about external or internal energy, Bhute. This is not about external or internal. This is actually this is about internal story. No? This is an internal story. So potential energy means actually I need to explain this is a type of potential energy because we are going to change the position. We are going to change the position. So if we want to change the position, and to change the position, we should apply a force. That means it is a type of potential energy. Therefore, these atoms of these particles have a type of potential energy, because if you want to change their position, I have to apply an energy. I have to supply an energy. Okay. Did you get my point? Hi. So that means internally that those particles have two type of energies. What are those? Kinetic energy due to vibration and a type of potential energy due to the intermolecular bonds. Okay. Write down this thing in a new paragraph. Therefore, the internal particles have two type of energies. Kinetic energy due to vibration, and type of potential energy due to intermolecular bonds. Okay. Right under this. The sum of these two energies, the sum of these two energies inside an object is called as internal energy of that object. Internal energy. Okay. So internal energy is equal kinetic energy of particle plus potential energy of particles due to intermolecular bonds. මේක ලියලා කොටු කරගන්න. මේක අතිශය වැදගත් කාරණාවක්. මේක තමයි පුතේ කෝ එක. මේක තමයි කෝ එක. දැන් මේ යන්නේ කෝ එකට. හරිද? Therefore, you should understand this one very well. මම මේ මුල් ටික ඔයගොල්ලොත් එක්ක කතා කර හිමින්සරේ කරන්නේ මේක තමයි පුතේ තන්නේ කරම හීට් පාඩමේ මේ බේසික්ම අයිඩියා එක මේක අපිට ඇප්ලයි කරන්න පුළුවන් හැම තැනටම. දැන් අපි මේ කතා කරේ මොනවද? particles කියන්නේ මොනවද? particles කොහොමද තියෙන්නේ? කියන්නේ vibrations තියෙනවා, intermolecular bonds තියෙනවා. So due to vibrations and intermolecular මේ කියන්නේ vibration intermolecular bonds නිසා යාට තියෙන kinetic energy එක, potential energy එක. ඔන්න ඔය කියන concept එක අපිට පුතේ හැම තැනටම apply කරන්න පුළුවන්. apply කරලා තීර ටික බොහොම ලස්සනට තේරුම් ගන්න පුළුවන්. Okay. හරි. Yes. No. Understand this one. Potential energy means, yeah, if you want to break means if you want to, no, actually with it, then okay, illegally in the potential energy means if you want to change the position of the particle, if you want to change the position of particles, we have to apply an energy because that particle is bounded by intermolecular bonds. Therefore, we have to supply some energy to change the position of the particle. Okay? So, if you want to change the position, and to change the position, if you have to apply some energy, that energy is a type of potential energy because that is the definition of potential energy. Okay, that is the definition of potential energy. Is if there's an energy due to the change of their position, that is a type of potential energy because this is the definition of potential energy. Okay. හරිද? මෙතන මේකේ තියෙන්නේ අතරම දැන් අපි මොකක් කර මොලිකියුල් එකක් මොකක් කර මේ ඇටම් එකක් අපි එළියට ගන්න ඕන නම් ඒ මේක assumption එකක්. This is an assumption. Okay? This is assumption. මේක එළියට මම කියන්නේ මේක this is assumption. ඒ කියන්නේ well, look at this one. If we want to change the position, okay, that's mean we are not going to change the position. Okay, we are not going to change the position of that particle. If we want to change the position of particle, so if you want to change the position of particle, we have to apply some energy. Okay, so this is assumption. So if you want to change the particle, that means if you want to change the particle means we are not going to change the particle, but if we want to change the particle, we have to apply an energy. So energy relates to change the position of that particle is a type of potential energy. That's why it is categorized under potential energy. If you want to change the name of potential energy, it's okay. But there's an energy. You should understand there's an energy. Do not consider about name. Okay, do not consider about name. You should understand one thing. There should be energy, no? නේද? එච්චර ඔයගොල්ලෝ තේරුම් ගන්න ඕනේ. මේක නම ගැන හිතන්න එපා. නම ගැන හිතුවොත් මේක කරන්න බෑ. If you want to change, why? They are bound together, no Buddha. They are bound together by these intermolecular bonds. Okay? These, suppose this is a particle. This particle is bound together. These particles are bound together by intermolecular bonds. So if we want to change the position of this particle, you have to break these intermolecular bonds. You have to break these intermolecular bonds. Otherwise, you cannot change their position, no? නේ? නිකන් හිතන්න ඔයාව හතර වෙනින් අතන් ඉන්නවා කියලා කවුරු හරි. ඔයාව මේ වගේ මොකක් හරි බ්ලන්ුවකින් බෙදලා තියෙනවා කියලා හිතන්න. හරිද? එතකොට ඔයාගේ පොසිෂන් එක චේන්ජ් කරන්න ඕන නම් ඔයා මේ බෙදලා තියෙන ලොන්ඩ් එක කපන්න එපා. නැත්තම් කොහොමද බේරගන්නේ? ඈ? ඒ වගේ. හරිද? So suppose this particle is bound using these intermolecular bonds. So if you want to change the position of this particle, you have to break this intermolecular bond. If you want to break this intermolecular bond, you have to apply a force, apply an energy. If you apply energy, then you can break this intermolecular bond. නිකන් හිතන්න එහෙමනේ. ඔයා නිකන් බෙදලා තියෙනවා කියලා හිතන්න. මේ ඔයා නිකන් බෙදලා තියෙනවා කියලා හිතන්න වාගේ මෙහෙම මේ අත් කපුල් ටික ලනුවකින්. So if you want to escape, you have to cut this rope, no? That means you have to apply some energy and cut these ropes, no? Yes. We can. Huh? We can. We can consider it as springs. Huh? අපිට ඒක කතා කරන්න පුළුවන් ඉස්සරහට ස්ප්‍රින්ග්ස් කොහොමද මේ විදිහට කතා කරන්නේ කියලා. හරි? but මේ නම ගැන හිතන්න එපා. ඔයාලට potential energy කියන නම දිරවන්න නැත්නම් වෙනමක් දාගන්න. ඔයාලම මොනවද කමන්නේ. But you should understand this thing. You should understand this thing. Due to this intermolecular bonds, this particle have an energy. Okay. That thing. Did you understand that thing? Due to that intermolecular bonds, those particles have an energy. තේරුණාද? අන්න ඒක තේරුණාද කියලා කියන්නේ? මට එච්චරයි ඕන. It's true? Me? Me තේරුණාද? මෙච්චර ගන්න ඕනේ පුතේ. මේ intermolecular bonds නිසා මෙයාට එනර්ජි එකක් තියෙනවා. මොකද intermolecular bonds ටික break කරන්න ඕනි. මෙයාව escape කරන්න. intermolecular bonds break කරනවා කියලා කියන්නේ අනිවාර්යෙන් එනර්ජි එකක් apply කරන්න එපා. තේරෙනවද? ඒ නිසා intermolecular bonds ටික නිසා මෙයාට එනර්ජි එකක් මෙයාගේ තියෙනවා. So due to the intermolecular bonds, it has energy. Okay? You have to understand that thing. If you don't like to name it as potential energy, that's okay. But you should understand there is an energy. And okay, on the other way, so connect there again. Okay. So now we can go to define heat. Okay. Now you know, now there are two types of energies. There are two types of energies inside materials, inside particles. They are inside particles, no? They are inside particles within a matter or object. Okay. Now we know there are two types of energies in these particles. One is due to vibration, other one is due to the intermolecular bonds. Okay. So if there's a external energy, suppose if any external energy can change, if any external energy can change the internal energy of an object or matter, that external energy is called as heat. That means if I supply a heat to an object, the internal energy of that object will change. Okay. If the internal energy of that object is changed, heat can be released. Heat can be released. Heat can be released. Therefore, heat is an external energy that can change the internal energy of an object. Okay. So by supplying heat energy, we can change the internal energy. That means either kinetic or the potential energy of those particles. Okay. Did you get my point? මොකක්ද heat එක කියන්නේ? heat එක කියලා කියන්නේ පොතේ එහෙනම් අපි අර අපේ internal energy එක change කරන්න පුළුවන් externally දෙන energy එකට අපි කියනවා heat එක කියලා. ඒකෝ heat එක දුන්නහන් මෙයාගේ internal energies වෙනස් වෙන්න පුළුවන්. ඒ වගේම internal energies වෙනස් වුණොත් මොකක් හරි හේතුවක් නිසා heat එකක් release වෙන්නත් පුළුවන්. ඔකයි කියන්නේ. හරි. Did you understand that one? Did you get my point? That's mean, Buddha. Is there no energy than heat? What did you mean by? That's mean to change internal energy. No. So that is the definition of heat. Okay. So if any external energy can change the internal energy, that external energy should be a heat. No other external energy can change the internal energy. No other external energy can change the internal energy of an object. Only the heat can change the internal energy of an object. That's why this is so important. Okay. You know. Heat or normally we call as thermal energy. Both are okay. Heat or thermal energy. So heat or thermal energy means the external energy that can change the internal energy of an object. Okay. So write a topic. What is it? No, we cannot do that. It is a mechanical thing. So, when you break an object, you have to apply force. When you apply force, there will be a friction. Due to the friction, there will be a heat energy. That heat energy can be used to break the intermolecular bonds. Okay, that is the thing. And otherwise you cannot. And did you get my point? Very good question.
Can you tell the
Sorry, Budhe? No. The topic, fifth one, no? Fifth one, no? What is heat or thermal energy? The type of energy that can change the internal energy of an object. The internal energy of an object is called as heat or thermal energy. Heat or thermal energy. Thank you. Okay, draw this figure. Okay, right under this, right under this. Right under this. That is, comma, when thermal energy is given to an object, its internal energy increases. Its internal energy increases.
Its internal energy.
Uh, when thermal energy is given to an object, its internal energy increases. Its internal energy increases. When thermal energy slash heat slash heat is removed from an object, is removed from an object, okay, when I will repeat that thing, okay, okay, when thermal energy or heat, thermal energy slash heat is removed from an object, its internal energy decreases. Its internal energy decreases. Therefore, heat is an external energy. Heat is an external energy that can change the internal energy of an object. That can change the internal energy of an object. Okay. Okay. Then heat is applied to the object. Okay. Now we are going to discuss when heat is applied. When heat is applied to an object, what will happen to that object? Okay. Okay. Please listen to me very carefully. All right. Everyone, please look at the board. Okay. When heat is supplied to an object, heat is a form of energy. Heat is a form of energy, and that can change the internal energy of that object. Okay. When heat is supplied to an object, the first thing, when heat is applied to an object, the first step is its kinetic energy is start to increase. That means if a heat energy is supplied to an object, these particles receive that energy. After receiving that energy, their kinetic energy, that means vibrations, kinetic energy will be increased. That is the initial state. Okay. Initially, the potential energy does not change significantly, but the kinetic energy will be increased. That means, like this. Suppose my two hands are holding with two other person. Okay, we are holding our hands. Okay. Suppose now I'm shaking my hands. Okay. Now I have energy. No. Suppose I have received additional energy. I have received an additional energy. Due to that energy, my vibrations are my strength of vibrations is increased. Okay, degree of vibration. So I start to vibrate fast. If we supply more energy, the vibration, what will happen? I can vibrate, I can shake my hands very fastly. Okay. So there is a point that we cannot hold our hand. Until then, we can increase our vibration speed. No, until then up to that point, we can increase our vibration speed. No, therefore, when heat is supplied to this object, what will happen? The vibrations of particles, the degree of vibration, that means the vibration speed will be increased. Okay. Initially, the intermolecular bonds does not change significantly. The only thing is vibration is increased. Okay. Suppose the heat energy is supply more and more heat energy. We have supplied more and more heat energy. Then what will happen? It will start to vibrate very fastly. Okay. There is a point that intermolecular bonds. Yes. So there is a point that intermolecular bonds cannot bear that vibration. At that point, the intermolecular bonds will be break. Okay. So up to that point, the intermolecular bonds doesn't change significantly, but the vibrations increase. So when we supply heat energy to object, the kinetic energy of particles will be increased. Okay. Due to the increment of the kinetic energy, the degree of vibration means the strength of vibration will be increased. The strength of vibration will be increased. Therefore, they will start to vibrate very fastly. So that that can be continued up to some extent, but there will be a limit. Okay. So if I supply the heat energy, more and more, they will try to vibrate very fastly. So there is a point that intermolecular bond is sufficient. It's not sufficient to bear that vibration. Like my hands. If I shake my hands so fastly, what will happen? Our bonds will be break, no? Our bonds will be break. Therefore, there will be a point that intermolecular bond will be break due to the vibrations of particle. Did you get my point? Heat okay. Okay. When you supply heat, the first thing happen is the kinetic energy of those particles will be increased. So we can sense that increment. We can sense that increment. We can sense this increment of kinetic energy.
Change of nature, state.
No, it's still it's steady state. It's the same. We can feel or we can sense the change of kinetic energy.
Temperature increase.
Temperature. When we supply heat, what will happen? Suppose this is a steel rod. We are going to supply heat at this end. What will happen? Its temperature will be increased. We can feel that thing. No, we can feel that thing. Okay, there is temperature. So when we supply a heat energy, to an object, the first thing happen is the kinetic energy. The kinetic energy of that particle will be increased. Due to the increment of kinetic energy, we can sense that thing by changing their temperature. So temperature is a sensation, that depends on the kinetic energy of particles. So if the kinetic energy of particles changes, temperature changes. So I can feel, or you can feel, the change of kinetic energy by changing the temperature. Therefore, temperature is a sensation or sense. It is a sensation. Okay. That depends on the kinetic energy of particles. Okay. Temperature temperature okay. So temperature is a sensation. So that depends on the kinetic energy of particles. So once we supply heat, heat energy or thermal energy, the vibration of those particles will be increased. They start to vibrate very fastly. That means the kinetic energy change. It has been changed. Okay, so that change can be feel externally by changing the temperature. Okay, we can sense that thing. Okay, that means that means temperature is a sensation that depends on the kinetic energy of particles. Okay. All right. This is very critical explanation. This is very critical explanation because when we are discussing about gases, especially in ideal gases, there's only one internal energy because in gases there's no intermolecular bonds in ideal gases. We can assume there's no intermolecular bonds because they are very weak. Okay. Therefore, if you consider about ideal gases, the total internal energy is consist of kinetic energies. Kinetic energy. Okay. Therefore, this is very important, very critical explanation. Okay. මේක තේරුණාද කාටද මොකක් කර මේකේ අපහසුතාවක් තියෙන කාට හරි කියන්න මේක very critical explanation එකක් මොකද මේක තමයි මං කිව්වේ පෝ එක මොකක් හරි තේරෙන්නේ නැත්නම් අහන්න පුතේ කිසිම ප්‍රශ්නයක් නැත හරි තේරියද okay then write a topic what happens when heat is applied to an object. When heat is applied to an object. Write down when heat is given, when heat is given to an object, the first thing that happens is when heat is sorry. This is a repeat. Okay, don't write it again. When heat is given to an object, the first thing that happens is increase in the kinetic energy, increase in the kinetic energy, increase in the kinetic energy, increase in the kinetic energy of the particles, of the particles, of the particles that received the heat energy, that received heat energy, that received heat energy. That means at the particles start vibrating faster, at the beginning, the potential energy does not change significantly, Therefore, it can be assumed it can be assumed that the thermal energy the thermal energy supplied the thermal energy supplied is entirely obtained to increase the kinetic energy of the particles. The kinetic energy of particles to increase the kinetic energy of particles. Okay. अब temperature का ये लगा week के करूँ ना तमाम ऊपर थोड़ा पिलाने वाली जाएगी हाँ. Okay. Do you have any questions up to now? හොඳයි. පොඩක් හැමෝම අහගන්න පොඩි දෙයක් තියෙනවා කතා කරන්න. දැන් ඔයගොල්ලෝ මේ යුනිට් එක ගත්තොත් මේ යුනිට් එක අනිවාර්යයෙන් හොඳට හිතන්න තියෙන යුනිට් එකක්. මහා ලොකු අමාරු දෙයක් නැහැ. මහා ලොකු අමාරු දෙයක් නැහැ. හැබැයි හොඳට හිතන්න තියෙන එකක්. හරිද? ඒ නිසා ඔයගොල්ලෝ ඔය ප්‍රශ්න අහන්නේ ගොඩක් හොඳයි. ප්‍රශ්න අහන තමයි ඔයගොල්ලෝ තේරුම් ගන්න ඕනේ. හැබැයි නිකන් බෑ. දැන් ඔයගොල්ලෝ මේක ගිය ගමන් ආයෙත් පාරක් හොඳට නෝට් එක කියවන්න. හොඳට නෝට් එක කියවලා ආයෙත් පාරක් හොඳට ඔබ ස්ටඩි කරන්න. තේරුම් ගන්න බලන්න. මොකක් කරලා ප්‍රශ්න තියෙනවා ඒ වගේ මගෙන් අහන්න. හරිද? මොකද ඔබ හොඳට තේරුම් ගන්න ඕන සබ්ජෙක්ට් එකක් හීට් කියලා කියන්නේ. මේ හීට් එක හරියට තේරුම් ගත්තොත් ඕනම ක්වෙස්චන් එකක් බොහොම ලේසියෙන් හදන්න පුළුවන්. හරිද? මොකද ඒකේ අර අමාරු කැල්කියුලේෂන්ස් නෑ. හරිද? අමාරු කැල්කියුලේෂන්ස් නෑ අපිට තියරි එක ඇප්ලයි කරන්න හරිය දන්නවා නම් මාරු ලේසියෙන් හදන්න පුළුවන් සබ්ජෙක්ට් එකක් මේ හීට් කියලා කියන්නේ. හරිද? දැන් මැකැනික්ස් එක ගත්තොත් ඒ මැකැනික්ස් වල එහෙම සාමාන්‍යයෙන් අපිට ඔය මැක්ස් කරන්නට ලේසි හේතුව මැක්ස් කරන්න කට්ටියට මැකැනික්ස් ලේසි වෙන්නේ මැක්ස් වල අපිට අහු වෙන සබ්ජෙක්ට් ඔක් මේ පාඩම් ඔක්කොම ටික මැකැනික්ස් වල තියෙන. ඒක නිසා මේ ඒවා අපි ගොඩක් ඩීප් කියනවා. ඒක නිසා මැකැනික්ස් ගන්න දුන්නොත් මැක්ස් කරන්න කට්ටිය ලේසි. මොකද ඒක මැක්ස් පැත්තේ වැඩි. හරිද? බයෝ කරන වැඩි ගොඩක් අමාරුයි. හරිද? එහෙම තමයි ඉතින් නමුත් එහෙම නොවන අවස්ථා තියෙනවා. හරිද? මේ හැබැයි මේ හීට් ගත්තට පස්සේ මෙතනින් එහා ඒ ලෙසන්ස් එක ගත්තට පස්සේ මේක එහෙම දෙයක් නෑ. ඕනි කෙනෙක්ට තේරුම් ගත්තොත් බොහොම ලේසියෙන් ක්වෙස්චන් එකට ආන්සර්ස් දෙන්න පුළුවන්. ඒ නිසා හරියට බලන්න මම ආයෙ පාරක් ඔයගොල්ලන් කියන්නේ දැන් වෙලාවක් නැත්තම් හෙට හරි කමන්නේ නැත්තම් පුළුවන් ඉතින් වැඩි කල් ගන්න එපා. මොකද ආයෙ යමතක වෙන්න පුළුවන්. අනිවාර්යෙන් බලන්න. ඊළඟට තවදයක් කියන්න ඕනේ අනිවාර්යෙන්ම මම දැන් මොනවද රෙකෝඩින්ග්ස් අප්ලෝඩ් කරනවා. රෙකෝඩින්ග්ස් අප්ලෝඩ් කරලා පස්සේ මම නෝට් එවන්න. නෝට් එවන්නදී ගොඩාක් ළමයි ඉන්නවා. ඉංග්‍රීසි මීඩියම් කට්ටිය විශේෂයෙන් සිංහල මීඩියම් හැමදාම කියලා සිංහල මීඩියම් දරුවෝ ඔක්කොම වගේ වැඩ කරනවා. හරිද? ඒ නිසා සිංහල මීඩියම් සෙක්ෂන් එකේ ඉච්චර ලොකු ප්‍රශ්නයක් නෑ. මට මේ ඉංග්‍රීසි මීඩියම් කට්ටියගේ තව පෙන්ඩින් දේවල් ගොඩක් තියෙනවා. හරිද? ඒ නිසා මෙතනින් පස්සේ මම නෝටිස් එකක් දාන්නම් මේකේ. මම රෙකෝඩින්ග්ස් දෙනවා අවශ්‍ය කට්ටියට. හැබැයි රෙකෝඩින් එක තියෙන්නේ දවස් 3ක්. රෙකෝඩින් එක දවස් 3ක් තියෙන. එතනින් පස්සේ ඒක ඔටෝමැටිකලි ඩිලීට් වෙනවා. පේන්නේ නැහැ. දවස් 3න් පස්සේ කාටද අවශ්‍යතාවයක් තියෙනවා වැලිඩ් රීසන් එකක් එක්කගෙන නැත්තම් හම්බ වෙන්නේ නැත. දවස් 3යි තියෙන දවස් 3ට වඩා දෙන්නේ නැහැ. නැත්තම් වැඩක් නැහැ. මොකද දැන් පෙන්ඩින් දේවල් කියලා පුරා. තව ළමයින් දැක්කම රීල්ස්ට් පොසිටිව් මං කියේ මං මුල දෙයක් මං ඉල්ලුවේ නෑ. මං වෙක්ටර්ස් මං ඉල්ලුවේ නෑ ඕගොල්ලන්ගෙන්. මං යුනිට් ඇන්ඩ් ඩිමෙන්ෂන්ස් ඉල්ලුවේ නෑ. මං ඉල්ලුවේ දැනට කරන ලෙසන්ස් දෙක. මොනවද? ලීනියර් මොෂන් එකයි පොසිටිව් එකයි. ඒවා මහා ලොකු ලෙසන්ස් ගන්න ගිහින් නැහැ. හරිද? ඒ නිසා ඕනි කෙනෙක්ට එක දවසක් ඇති ඒකට අග්ගල් කම්ප්ලීට් කරගන්න. හරිද? ඒ නිසා ඒක ඇත්තටම මේ අවශ්‍ය කියන්නේ කෙරෙලා කෙනෙක් කරන්න ඕමනාවක් තමයි තියෙන්නේ. වෙන දෙයක් නෙවෙයි. ඒ නිසා කරන්න ඕමනාවක් නැති කට්ටියව අරගෙන යන්න අවශ්‍යතාවයක් නෑ මට. කරන්න ඕමනාවක් තියෙන දරුවෝ විතරයි එක්කන් යන්න වෙන්නේ. නැත්නම් මේක කරන්න බෑ උතේ. හරිද? නැත්නම් අර හැමෝම එනකන් හිටියොත් එහෙම අර මේ අනිත් කට්ටිය උනත් ඒ කියන්නේ හොඳට වැඩ කරන කට්ටියට ඒක ලොකු අසාධාරණයක් වෙනවා. හරි පුතේ කවුලක් නෑ. අතන මේ ගොඩක් හොඳයි මේ නවතින අපේ දරුවෝ කියන්නේ මේ බොහෝම වේගෙන් ටක්ගල් කම්ප්ලීට් කරනකොට තමයි අපේ දරුවෝ හිටියේ. ඒක මාර්ග විදිහට ඇප්‍රීෂিয়েට් කරනවා මගේ ළමයි. හරිද? ඒ නිසා මේ ඒක ඔයගොල්ලෝ ඉංග්‍රීසියෙන් මට දෙන්න එක ප්‍රශ්නයක් නෑ මම. ඒවා පරණ රෙකෝඩින්ග්ස් මම මුත් කරන්නේ නමුත් මෙතනින් ඉස්සරහට within 3 days complete කරන්න ඕනි හැම ළමයාම. හරිද? එතනින් එහාට දෙන්න බෑ. මොකද මේ නැත්තම් රෙකෝඩින් එක කියන එකේ තේරුමක් නැති. හරි. වැඩක් නැහැ පුතේ. ඒක නෙමෙයි මොකන්නේ. ඔයාලා හරියට per week එකේද මේ week එකේ දෙන වැඩ මේ week එකේ ඉවර කරන්න ඕනේ. ආයි week එක ගිහලා වැඩක් නැහැ කරන් තේරුමක් නැහැ. හරි. හැබැයි ස්පෙෂල් කේස් එකක් තියෙනවා මම මට ඒක පැහැදිලිව කියන්නේ. මම ඒ ළමයාට ස්පෙෂල් දෙනවා. හැබැයි අනිත් හැමෝටම රෙකෝඩින්ග්ස් තියෙන්නේ දවස් 3 විතරින් පස්සේ අවශ්‍යතාවය තියෙන කට්ටියට අරගන්න පුළුවන්. හරිද? තමයි ඉතින් ලයිව් ක්ලාසස් වෙන කට්ටිය රෙකෝඩින් ඕනි වෙන අවස්ථා තියෙනවා. මොකද ගොඩක් වෙලාවට මම දැකලා තියෙනවා මේ ලොග් අවුට් වෙනවා, ලොග් වෙනවා, ලොග් අවුට් වෙනවා, ලොග් වෙනවා. ඒ වගේ තැන්වලදී මිස් වෙන්න පුළුවන් කියන දේවල්. ඒ නිසා ලයිව් ක්ලාසස් වෙන කාමයි තමයි රෙකෝඩින් අවශ්‍යයි. මම ඒක අනිවාර්යෙන් පිළිගන්න කාරණයක්. රෙකෝඩින් ඕන මෙතන වෙනවා අවශ්‍යතාවයක් අනුව. හැබැයි අර කන්ඩිෂන්ස් ටික තියෙනවා. මට එවන්න ඕනේ ඕගොල්ලන්ගේ පරණ නෝට් ටික. ඊට පස්සේ මේක දැන් තියෙන්නේ within 3 days විතරයි. හරිද? ඊළඟට මට අද දෙන්න බැරි වුණා ඕගොල්ලන්ට මේ quick recap එක. මොකද වෙලාව තිබුණේ නැහැ. මම පරක් වුණා පටන් ගන්න ඕන. ඒක නිසා මම ඒක දුන්නේ නැහැ. මම ඒක අප්ලෝඩ් කරනවා පුතේ. දැන් ක්ලාස් එක උඩට පස්සේ අප්ලෝඩ් කරනවා. ඔයගොල්ලෝ ඒක කරන්න. දැන් හෙට දවස් තියෙනවා. අනිද්දා ඔයගොල්ලන්ට ගන්න පුළුවන්. ඒක කරන්න. කරලා ඉවර වෙලා ඒකේ මාක්සින් බලන්න මම quick recap එක දාලා තියන්න. ලොකු වෙලාවක් යනවා. ඉතින් 10ක වගේ වැඩක් නේ. quick recap එක දාලා තියන්න. ඒක කරලා තියන්න මේ සන්ඩේ ක්ලාස් එකට එද්දි කරලා තියන්න. හරි. අපිට සන්ඩේ ක්ලාස් එකේදී පොඩ්ඩක් ඔය ටික ඩිස්කස් කරන්න තියෙනවා. quick recap වලදී දීපු ආන්සර්ස් ටික මොකද සමහර questions කළ යුතුයි කියලා මම හිතනවා. ඒක නිසා මම සිංගල් මීඩියම් කට්ටියක හැමෝම quick recap කරලා තිබ්බා. ඒ නිසා සිංගල් මීඩියම් කට්ටියට මම ඒක රිවිව් වීඩියෝස් එකක් දැම්මා. මම ඉංග්‍රීසි මීඩියම් තව දැම්මේ නැති. ඉංග්‍රීසි මීඩියම් වල භාගයක් තියෙනවා තව කරලා. හරි. භාගයක් quick recap එක කරලා නැහැ ඉතින්. ඉතින් එතනින් එහාට ඉතින් කරලා නැති මිනිස්සු ඉන්නවා කොහොමද? එක්ක මේ රිවිව් එකක් දාන්න. හරි. ඔය ප්‍රශ්නේ හැබැයි ඉතින් ඒක ලයිව් ක්ලාසස් කියන්නේ දැන් ඔය කරපු ළමයිට අසාධාරණයක් වෙන නිසා මම ඔය සන්ඩේ ක්ලාස් එකේදී සමහර questions තියෙනවා කල යුතු questions ඒවා පොඩ්ඩක් මම ඩිස්කස් කරනවා. හැබැයි මම ආයෙ පාරක් ඉල්ලන්නේ මේ රෙකෝඩින්ග්ස් බලන ළමයිනුත් ඉල්ලන්නේ පුළුවන් තරම් quick recap එක කරන්න කරලා සබ්මිට් කරන්න. මට එතකොට රිවිව් එක දෙන්න පුළුවන්. සබ්මිට් නොකර රිවිව් එකක් දීලා රිවිව් එක රිලීස් කරලා තේරුමක් නැහැ. ඉතින් ආයේ කිසිම දෙයක් තේරුමක් නැහැ. ඒක. ඒ නිසා හැබැයි ඉතින් මේකත් හැම වෙලේම වැදගෙන යන්න බෑ. කරන්නේ නැත්නම් ඒ කරන්න ඉති කට්ටිය අතල්ලා තමයි මට යන්න වෙන්නේ. හරිද? ඒක නිසා මේක හොඳට මතක තියාගන්න. හැබැයි ඉතින් කරන්නේ නැති කට්ටිය මට වැඩිකල් තියාගන්නත් බෑ. තේරුමක් නැහැ. මොකද මට මගේ ස්ටෑන්ඩඩ් එකක් තියෙනවා පුතේ. මගේ ක්ලාස් එකේ තාම කිසිම එකක් වෙල්ලා නැහැ. මම ඒක මනිටර් කරගන්න කිසිම විදිහකින් මම කැමති නැහැ. ඒ නිසා කවුරු ළමෙක් අර කියන දේවල් කරගන්න බැයි නම් අනිත් ළමයි එක්ක යන්න බැයි නම් මේ මට කියන්න විදියක් නැහැ. මොකද දැන් අර SUS සම් වෙනවා අනිස තව සතියක් දෙන්න තව සතියක් දෙන්න නෝට් එක එවන්න තව සතියක් දෙන්න නෝට් එක එවන්න කියලා. දැන් ඒවා තාම නෝට්ස් එවලා නැහැ. ඉතින් ඔය සති ගණන් ඉල්ලපු ළමයින් තාම නෝට් කියලා නැහැ. මම දන්නේ නැහැ මේ සතිය ඒ කියන්නේ එහෙම කරන්න එපා පුතේ කරලා ඒ කියන්නේ පොයි කාලේ ඔය කරන්න. හරිද? ඔයගොල්ලෝ තාම තේරෙන්නේ නැහැ. තාම තේරෙන්නේ නැහැ. තව ටුට්ට කාලයක් යද්දි තේරෙයි වැඩ ලෝඩ් එක දුන්නාට පස්සේ. දැන්ට උනත් තේරෙයි දැන් අපි දැන් ලෙසන්ස් 3ක් කරනවා. ඔය ලෙසන්ස් 3 නෝට් 3 ලියනවා කියන එක ලේසි නෑ. ඒකයි කියන්නේ එක සතියක් මිස් වුණොත් එහෙම ලෙසන්ස් 3ක් හරිද? ඒකත් හොඳට මතක තියාගන්න. හොඳයි. ඒ නිසා මතක තියාගන්න කවදාවත් තියාගන්න එපා පුතේ වැඩ ගොඩ ගහගන්න එපා. මම මේ ආයිල්ලන්නේ ඕගොල්ලන්ගෙන් ඒ වැඩ ඒ ටිකට කරන්න. හරිද? මට ඕනි කොහොම හරි ඕගොල්ලන්ව හොඳම මට්ටමට හදන්න. හොඳම මට්ටමට හදන්න ඕනි. ඒ නිසා මට ඕගොල්ලන්ගේ ඒ පැත්තේ සහයෝගය හරිද? මගේ පැත්තෙන් මගේ උපරිමය මම දෙනවා. මගේ උපරිමය ගන්න ඕගොල්ලෝ. මම ඒකයි කියන්නේ. මගේ උපරිමය ගන්න ඕගොල්ලෝ දැනගන්න. ප්‍රශ්න අහන්න සමහර ළමයි ඉන්නවා ඉවරයක් නෑ ප්‍රශ්න අහන්න. හරිද? සමහර වෙන පොත් වලින් වෙනත් ප්‍රශ්න අහනවා. උපා ප්‍රශ්න අහලා ළමයි. හරිද? දැන් ඒ වගේ ඇත්තටම වදයක් වෙන තරමට වැඩේ යන්න. ඒ කියන්නේ එහෙම තමයි ඉගෙන ගන්න. හරිද? මම ඔයගොල්ලන්ට කිව්වා ඔයගොල්ලන්ගේ අර කරපු ටියුට්ස් දාන්න කියලා තව ටියුට්ස් දාන්න සිංහල වීඩියෝ බලන්න ඔක්කොම ළමයි දාලා තියෙනවා. දීපදේ පවුත් මේ පර්සනල් නම් මම ඉතුරු කට්ටිය මේ ගෲප් එක දාලා තියෙනවා. ඔක්කොම වගේ දාලා තියෙනවා. හරිද? ඉංග්‍රීසි මීඩියම් මම හිතන්නේ දෙතුන් දෙනා දාලා තියෙනවා. හරිද? ඒ නිසා පොඩ්ඩක් තේරුම් ගන්න මේ දැන් බර ගානක් ඉන්නවා ඉංග්‍රීසි මීඩියම් ළමයි. මේ අරගන්නේ 100% අරගන්න. දැන් ළමයෙක් සමන් මගෙන් ඇහුවොත් එහෙම එයාගේ ආන්සර්ස් ටික දැම්මොත් එහෙම මේ කරපු විදිය ඒ ළමයිට මම ගොඩක් කියා දීලා තියෙනවා. කරන්න ඕනේ කෙටි ක්‍රම. හරිද? ඒ නොලෙජ් එක අනිවාර්යෙන් ඔයගලන්ට අවශ්‍යයි. හරිද? ඒ නොලෙජ් එක අනිවාර්යෙන් අවශ්‍යයි. නැත්තම් ඔයගලන්ට එක්ස්පීරියන්ස් එකක් ඉන්නේ. ඔයගලන්ට එක්ස්පීරියන්ස් එක ගන්න ඕනි. ඔයගලන්ට වඩා උඩ මට්ටමක ඉන්න මිනිස්සෙක්ගේ. මේක හොඳට මතක තියාගන්න. හරිද? දැන් ඒ නිසා ඔයගලන්ට තනියම කරන්න පුළුවන් වපසරියක් තියෙනවා. ඒකේ ඇතුලේ ඔයගලන්ට ගන්න පුළුවන් අර එක්ස්පීරියන්ස් එක අර ඔයාලට වඩා දන්න කෙනෙක් එක්ක කතා කරලා ගන්න එක්ස්පීරියන්ස් එකත් එක්ක කතා කරන්න බෑ. ඒක නිසා ඒක හොඳට මතක තියාගන්න. ටියුට් එකක් ඇදුවට පස්සේ ඒක සර්ත් එක්ක කතා කරන්න. සර්ත් එක්ක කතා කරන සර්ට දෙන්න බලන්න. මොකද ඔයාලා හිතන විදිහට වඩා වෙනස් විදිහ තමයි අපි හිතන්නේ. හරිද? එතකොට ඒකෙන් ඕගොල්ලන්ට එම ගන්න පුළුවන්. හරිද? ඉස්සරහ ක්වෙස්චන් එකක් කරන්න ගොඩාක් දේවල් ගන්න පුළුවන් ඒ වෙලාවේ. ඒක හොඳට මතක තියාගන්න. හරිද? හොඳයි. ඒක කියලා අද ක්ලාස් එක විවර කරමු. එහෙනම් ක්වික් රීකැප් එක මම දාන්නම්. ඒක කරලා දාන්න. මොකක්ද ඒක ලොකු අමාරුවක් නෑ මේ පාර එක නම්. ඒක කරන්න ඒක අමාරුවක් නෑ මම දැන් දාන්නම්. අපිට කරන්න පස්සේ අර කරන්න බැරි වෙච්ච දේවල් කියලා නම් කරන්න බැරි වෙච්ච දරුවෝ හිටියනම් පළවෙනි මේ රීකැප්ස් ටික ඒවත් කරන්න පුතේ. එතකොට මට ඒක රිවිව් එක කරන්න පුළුවන්. ඒක පොඩි පර්ෆෙක්ට් වෙනවා ඊට පස්සේ. ඒ කියන්නේ හැමෝම කරාට පස්සේ මම රිවිව් එක කරන්නේ. හරිද? ඒ නිසා එකක් පොඩ්ඩක් බලන්න. හරි? හොඳයි. එහෙනම් අද ක්ලාස් එක නවත්තමු. හැමෝටම good night එහෙනම්. අයබෝන්.
ආයිබෝන්.
Thank you, sir.
Thank you, sir.